So let us continue. The base is 250 millimeters with the height equal to 500. So that's 500 millimeters cubed over 12. So we can get now the moment of inertia. So here that's 250 times 500 cubed divided by 12. So the answer is 2.6042 times 10 to the 9th mm to the 4th power. So that is our I. And the base, of course, since ang atong gisgutan is the maximum shearing stress, then if we try to draw the stress diagram, of course, makita na to ang maximum shearing stress here. So let me just draw the stress diagram. So we can find the maximum stress at the portion where neutral axis is found. So na diri ang max, no? So na siya corresponding shear stress in every fiber. So na diri dapita makita ang maximum shearing. So therefore the base is equal to that one. So here the base is 250 millimeters. So karon, let us solve for the Q. Q is the product of the area times the location of the center of the area padung sa neutral axis. Okay, since nagisgot man ta o maximum shearing stress, then we're trying to describe the area either above the neutral axis or below the neutral axis. Why? Kay ang fiber nato na aman nga gipangita is nasa neutral axis. So somehow you have to choose either babaw sa imuhang gipangita nga stress or sa ubos nga area. So mora gyud imong kapilian. So since ato man gi-describe is here, then we could choose either above or down. So I'll just use this area sa babaw. Anyway, ang area sa babaw, area sa ubos are just the same. So this is the area that we will be getting. So the area is, so just right here the area, and this is half of 500, which is 250, and 250 as the base. Therefore the area is 250 times 250. So that one is 62500 square millimeter. And what is the barred Y? Meaning the location of the centroid of the area. Okay, so where is the location of the centroid of the area that we are using? So since this is a square or a rectangle or a quadrilateral, polygon, so we have the centroid here. This is found at 1/2 of 250. So by the way, this is barred Y, and barred Y is 1/2 of 250. Okay, so I hope na clarify to siya, no, that the definition of the barred Y is the location of the centroid of the area being considered padung sa neutral axis vertically. So that's going to be 250 over 2. and this is 125 millimeters. Alright, so with that, we can now use the area as 62500 times 125 as the bar y, and we now get the Q. 62500 times 125, the answer is 7,812,500, and the unit is millimeters cube, because an area is in square millimeter, then bar y is in millimeter, so you have cube. All right, so let's collect these values because we will now be substituting this. And do not forget also that our shear max is 550. So mag-get na nato ang maximum shear, and that's equal to the maximum shear force, no? So the maximum shear force is 550 newtons, with the Q equal to 7,812,500, and this is in mm cube. Then of course our I is 2.6042. 2.6042 times 10 to the 9th power, and this is mm to the 4th, times the base of 250 mm, and this is our shear stress maximum. So let's try to cancel out some of the units. If you try to observe, we have m cube here and m to the 5th power. So ang mahabilin nga unit, it's going to be Newton per square millimeter, and this is equal to megapascal. Right, so let's calculate. 550 times 7,812,500 divided by 2.6042 times 10 to the 9th power times 250. So the shear stress, we have, it's 550, and then yes, the answer here is 0.00666 megapascal. And to make it in kilopascal, or at least dili siya close to 0, all we have to do is multiply it with 1000, or that's 6.6 kPa. This is our answer. And this is our shear max. Let's continue with the next one.